section 2.3, part 2. We just completed the equal to problems. Now we're going to look at the less than problems. As with all inequality problems, you will be graphing and you will be shading. We're going to give our answers in interval notation. Less than problems have answers that are bounded. That is, you will never have an infinity in your interval notation. Basically, what we mean by bounded is, imagine you have a little graph here. We're going to end up with something like this, shaded, with two endpoints. Think of bounded as if you would be able to draw a circle around everything that you shaded. If it's unbounded, it would be going off to infinity in one direction, and you would not be able to put a circle around it. Okay? So that's just an aside. Okay, so let's look at working x, the absolute value of x, is less than or equal to 5. Just like with the equal to problem, we're starting off with a very simple example so that you can see how to work it. And actually, I'll be able to show you kind of why this makes sense here. So imagine I have a number line and I have 0 on it. What this is saying is it wants to find all the values that that are less than or equal to 5 units away from 0. That was the official definition of an absolute value. So what units are less than or equal to 5 units away? Well, if that's 5 and that's -5, what would be all of them that are less than or equal to 5 units away? Well, that's going to be everything from here to here. Now, add interval notation. Remember that when you have an equal to on it, you're going to use a bracket on both sides. Okay, this is what I mean by bounded. Our answer you could write a circle around it. Now, we got our answer just by understanding what an absolute value is. We didn't talk about how to get this answer. What we're going to do here when you have a less than problem, and the way you identify a less than problem, I should have said this earlier, is that the absolute value is on the less than side, is on the small side of the number. Okay? So the way we work this is we work this as a three-sided problem. You're going to do x is less than or equal to 5, which I pulled from right here. But on this side, I'm going to put the -5. Just like we have boundaries here, we're going to have boundaries here. Most of the time, we will have something that we need to work here. We're going to need to move things around and solve them. This is our simple example. Okay, now with all inequality problems, we're going to be graphing, and we'll be writing an interval notation here. We're going to be graphing and shading. Remember, the numbers I must see are the numbers involved. You can put other numbers in there if you want to. And since we're going to have to do shading and we're going to have to do interval notation, we mentioned this when we did these before. The homework will always ask you for interval notation first, and then the graph. It's easier to do the graph first and then go to interval notation. Since you're always asked for both, you should just go ahead and do both and just enter your answer in the order they ask for it. So I'm shading between these two, just like I did up here. And then your interval notation is your left-hand boundary with what you have here, comma the right-hand boundary, and the symbol you have here. So these would be your answer. Okay, so let's look at another less than problem, one that we're going to have to do some work on. The absolute value of r plus 5 is less than or equal to 20. Just like we did up here, you're going to write it with a positive, and then you're going to move over and write the negative on the other side. So I'm going to have r plus 5 is less than or equal to 20. And then on this side is less than or equal to -20. Okay, these signs should match on these problems. In general, you can have a mixture of signs on a three-sided problem, but not on an absolute value problem. Okay, remember how to solve these. You want your variable alone in the middle, and then whatever you need to do here, you have to do to both sides. So I'm going to subtract 5 from all of them, which will give me -25 is less than or equal to r is less than or equal to 15. So I'm going to come to my graph. I must see these two numbers, -25 and 15. And remember, figuring out where to shade on a three-sided problem is very easy. You literally shade between the two values you have. Okay. Now for interval notation, we pull it directly off of our graph. I have a bracket, -25, comma 15, and a bracket. What this is saying is if I choose any number in this shaded area, so -24.93, if I plug it in right here, do the arithmetic, it would be true. If I plugged in 14.99, plugged it in here, it would be true. But if I plugged in 16, it's not going to work. Okay? What we have found is every single answer to this. It's just we have infinite answers. Every single point in here is part of our solution. Okay. So let's try this one. The absolute value of 4x plus 1 is less than 21. Okay. This is just less than. The others were less than or equal to. It works the same way. So I have 4x plus 1 is less than 21. Now is less than, put the -21 on this side. Okay. I want my x alone in the middle. I need to move that 1. So I'm going to subtract 1 from all three sides. That gives me -22 is less than 4x is less than 20. Okay. Now I want the 4 alone. I need to divide by 4. Okay. -22 over 4 reduces to -11 over 2 is less than x is less than 5. Now don't forget that you have to be aware if you divide by a negative, you have to flip the signs, and you're going to have to flip both signs. Okay? We divided by a positive here, we didn't have to worry about it. Put these two numbers on your number line. -11 halves, and I messed up here. I should have just put a line here. And the reason for that is because this is less than, which means this needs to be parentheses. And this needs to be a parentheses. We shade between them. And our answer in interval notation would be -11 halves with a parenthesis, comma 5 parenthesis. Okay, so let's try absolute value of 5 minus x is less than or equal to 3. Okay, so I'm going to write -3 less than or equal to 5 minus x is less than or equal to 3. So I have what's inside the absolute value, and then the positive version, and the negative version. To solve this, I need to subtract 5 from all sides, and that gives me -8 is less than or equal to -1 is less than or equal to -2. No, -1x. Negative x, sorry. And there's an understood 1 right there. Okay, so we've got -x alone in the middle. We need positive x. We need to divide everything by a -1. And then when I divide by a negative, I have to flip my signs around, both of them. So I end up with 8 is greater than or equal to x is greater than or equal to +2. Now, if you had not flipped your signs, one way you can keep in mind whether or not you're supposed to flip it, I can cover up the middle and one of the signs, and it should be true. See, 8 is greater than or equal to 2. It is true. If I had not flipped the signs, I would have 8 less than 2, which is absolutely not. Okay? The numbers I have to see on here are 2 and 8. They're going to get brackets because they have equal to. Then I shade between them. And our answer in interval notation is going to be 2, 8 with brackets on the outside of both of them. So if I pick any number between 2 and 8, and plug it in here, it should give me something that is correct. If I choose anything on the outside of these, it's not going to work.